Hey everybody, today I'm pretty excited. We're going to talk about parent graphs and how they can change by shifting, reflecting, and stretching. Okay, so let's talk about these parent graphs. We call these parent graphs because they're the most basic version of these graphs. And we're going to look here and we see that here's a parent graph. It's linear. The linear parent graph is just x, where we know the slope is 1. It goes through 0, 0. This is the absolute value function, where it's just absolute value of x. We know it goes through 0, 0. It has a slope of 1 to the right and a slope of -1 to the left. This is the square root function, where we know a square root can't be negative, so it starts at 0, and it goes from there. This is a quadratic function, which is what we've been using. Parent function is y equals x squared. Starting at 0, 0, we go up and curve to the right and up and curve to the left. Here's our square root function, our cubic function, where we start at 0, 0. It goes up to the right, but it can be negative because it's cubed, so it can go down to the left as well. And then our last one is our rational function, which is just 1 over x. Now keep in mind, x cannot be 0. So the closer and closer x gets to 0, it gets bigger and bigger, bigger, or smaller, 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 but it doesn't actually ever touch 0, okay? So as x gets smaller to the negative, it goes, y becomes a smaller and smaller number, negative. And then as x increases this way, the overall number gets smaller and smaller, smaller, positive. Okay, so those are our parent functions. We're going to be using all these different functions as we talk about how functions can change. Okay, so let's talk about the transformations of graphs. Okay, so I'm going to just give us a very, very basic function. Okay, so we've got y equals, and then usually we'll see in something like an x, right? Inside here there's a parentheses. Now I'm going to show you all the different ways that we can change this graph. We can put a coefficient in front. We can put a coefficient in front of the x. We can put a term behind the x by subtraction. And we can put another term back here. Okay, so let's talk about what each of these do and where they're located. Okay, so we see a couple of different things. We see a value of a, which is a coefficient in front of the parentheses. We see b, which is a coefficient of x inside the parentheses, a minus c plus d, which d is just being added at the very end. So there's a few ways that we need to decode what is going on here. So I want you to first look at what's going on outside of the parentheses, okay? Outside of the parentheses is what you would call the vertical transformations, okay? Both A and D affect our graph vertically, and we'll talk about how in just a minute. Now, inside the parentheses affects the graph horizontally. Okay, so if we see a coefficient inside the parentheses, we know it is horizontal. Okay, now here's the other layer that we do. These two in front actually we'll make it in red. These two in front are either a compression, meaning something is getting smaller, or it's a stretch. or something is getting stretched larger. And the last one here is these two, okay, where these are what's called a translation, where we're either going right, left, or up and down. Okay, so I'm kind of giving you the tools here so you can decode your own changes to a parent graph that you see. Okay, so let's list this off. The value of A is a vertical stretch. If A is greater than 1, it's a stretch, and it's a compression if A is less than 1, meaning a fraction, okay? B is a horizontal stretch if B is less than 1, and a compression if B is greater than 1. And the reason is because it's a horizontal stretch or compression by a factor of 1 over B. Okay, so whatever we see here for B, you need to basically take the reciprocal of it and then think, okay, if the reciprocal of B was, let's just say if B was 7, the reciprocal is 1/7. If I multiply something by 1/7, it's going to be getting smaller. So that's going to be a compression. If B, let's say B was 1/3, the reciprocal of 1/3 is 3. If I multiplied something by 3, I'd be getting bigger or stretching. And that's because it's inside the parentheses. And I like to think of the parentheses, if it would help you, I think of parentheses as Funky Town. And that's because everything in Funky Town, you got to take a minute, you got to take a pause, and nothing is the way it seems, okay? So when you multiply by a coefficient here like B, you have to take the reciprocal of it, okay? Which leads me to the value of C. Wrong color. So here's my value of C. C is a translation, which is just basically a slide. And it's going to go left if C is positive. And it's going to go right if C is negative. Now here's the deal. Again, this is Funky Town. So whatever we see here, we're going to take the opposite. So if C is, let's say, 2, I would see that it was -2. So you take the opposite of it. And if it's positive in here, we go to the left. If it's negative in here, we go to the right. So normally it's the other way around, but because we're in Funky Town, we're taking the opposite, okay? And then our last one here is D, and D is just normal. It's outside the parentheses. It's not inside Funky Town. This is a translation, which is just a slide. If it's positive, it's going up. If D is positive, it's going up, and it's going down if D is negative, okay? The other thing that we haven't talked about yet is if A is negative, that's called a flip, where it would not just vertically stretch or compress it, but it would actually flip it across the x-axis, okay? And B, if it was negative, it actually flips it across the y-axis. Okay, so there's a lot of information in this little tiny box, but it is super important that you get all of this down, okay? Every single piece. Okay, moving on. Let's do an example. Compare the graph of each function with the graph of x cubed. So remember, x cubed looks like that parent function. Okay, I'm going to graph it right here where it looks like this. Okay, it goes through 0, 0. When x is 1, y is 1. When x is negative 1, y is negative 1, and so on. So remember, looking at this here, I can rewrite this as x cubed minus 1. Now, we're not doing any changes inside Funky Town or inside the parentheses. The only change I see is this right here. This tells me that it's a translation vertically, which is where we're going to go down 1. So I'm going to go ahead and put this one in green. Okay. So if I'm putting this in green, I'm literally just moving everything down 1 point, including that vertex or that point at 0, 0. Okay, now let's look at this one. We'll put it in pink. Okay, we are looking at a difference inside of our Funky Town. Remember, this value is just like C, where we take the opposite of this. So because it says negative 1, but we're really thinking the opposite, which is positive 1. So we're going 1 to the right. So from the black, which was our original parent function, we're going to go everything 1 to the right. Okay. And then our last one, we'll put in purple, has a couple of different things. So remember, this is that value of C. If I see positive 2, we're going to think, okay, it's really negative 2, which is going to the left. And then this positive 1 is going up 1. Okay, so we go, I'm going to take this point at 0. We're going to go up 1, to the left 2, and that's the center where everything else goes from. Okay. And finding equations of my graphs. The parent graph shown is x squared. Find the equation for each. So remember, this is just our parent function. Let's look at this one. Okay, so we know for this one here, it looks a lot like this, but instead of being at 0, 0, it's up 3. So they went up 3. So literally all we're going to do is we're going to take our x squared and we're adding 3 to it. So g of x equals x squared plus 3. And this one here looks the same, but instead of being at 0, 0, we went, from going here, we went 1, 2 to the left and 1 down. So we went 2 to the left and 1 down. So here's our x, here's our squared. I put that parentheses because I know when we have a left, that's a horizontal change. It has to go inside here. So remember, 2 to the left would normally be a negative 2, but because we're in Funky Town, we make it the opposite. So we put the plus 2 here for the 2 to the left. We go 1 down, which is outside, and to the right, we're subtracting it, and that's our h of x. We already talked about reflecting graphs. Compare the graph of each function. So remember that this parent function is the square root of x squared. Looks like that. If we're looking here, this negative in front basically just flips everything over the x-axis. Okay, so that negative in front on the A flips it over just like this. All right, let's look at this one. Remember, this one's on the B, which means it flips over the y-axis. So I'm going to take the graph, my parent function graph here, and I'm literally just going to flip it over the y-axis. Okay. And then this one's a little bit trickier. This one goes over the x-axis, and this tells me, pretend like there's a parentheses here, this tells me that there's something going on to the left too, because we go the opposite of the directions and then we go and we flip it. So from here, we would normally go left 1, 2, and it would normally look like this, but now it's going to be flipped across the x-axis, which is really going to look like this. Okay, so I did the dash because that was like its first version, and then we went down under the x-axis with it. Okay, and then these are the compressions and stretches, or in other words, non-rigid, which we don't really use that term in math I haven't seen it in ever, but the book likes to call it non-rigid, but we call them compressions and stretches. This parent function looks like this. It's our absolute value function. Here, it's a vertical stretch. So instead of going up 1 over 1, we're going to go up 3 over 1. So we're stretching it vertically. So we're going to start at 0, 0. And instead of going up 1 over 1, we're going up 3 over 1, like this. So it just looks a lot skinnier because it's going up faster. And that's this one. And then this one here is actually going to be a compression, a vertical compression by a factor of 1/3. Okay, which basically means instead of going up 1 over 1, we're going up 1/3 over 1. So it looks kind of like this. And it looks a lot wider because it's being compressed down